Hi, and welcome back to Hacker101. In this session, we're going to talk about file upload vulnerabilities. I've made references to these in other sessions, but we're going to dive deep now. These are interesting because there are a whole host of ways that uploads can be handled improperly, leading to everything from XSS to code execution and everything in between. Many people have never seen what a multi-part post, most commonly used for form-based file uploads, actually looks like, so here's an example. The header looks like a normal post for the most part, with the exception of the content type. That indicates 1, that it's a multi-part request, and 2, that each part is separated by the boundary specified in the content type. I suggest pausing here to take a look over this and really understand the components. The most obvious way to break this is via file names. When you upload a file, if you see that it retains some part of the original file name from the request, it's very possible that there are any number of vulnerabilities there. For instance, what if you upload a file called //test.php? MIME types are another interesting route for failure. Often the MIME type supplied by the browser is stored in a database along with a reference to the file on disk. Then this gets sent down to the browser when the file is accessed. The SQL injection, header splitting, which is something we'll talk about later, XSS, for instance, uploading an HTML file with the text HTML MIME type, but with an image file extension, and others. When uploading images particularly, sites will often attempt to validate that the file is an actual image, then just pass it through with no modification. The issue here is that even a totally valid image file can actually contain malicious content. For instance, PNG files can contain arbitrary chunks of data. These meet the spec, but can contain absolutely anything you want. This means that you can embed a bunch of HTML, and if the browser is told that the file is not an image, you may be able to execute arbitrary code. Given the breadth of issues, there clearly can't be a single mitigation to fix it all. So let's talk about common mitigations and how they can fail. In the vast majority of cases, files uploaded by users should not be hosted on the same domain as your site. The reason is that if you don't do that, same origin policy dictates that any JavaScript running in the context of the upload may be able to access and manipulate the site itself, just like a user could. In other words, you have no insurance if XSS does take place in the future, so store them on a separate domain. File names should never ever come from users. When a file is uploaded, I recommend generating a new file name either randomly or based on a hash of the file contents, and using extensions either based on the MIME type or the detected file type. Do bear in mind though that you should have a strict whitelist for file extensions, even if you're generating them yourself. If uploaded files are not being served directly from the file system, the issue becomes, what MIME type and disposition should we use? The general rule is that MIME type should be strictly whitelisted. If the indicated type isn't on the list, that's okay, as long as you send it with an attachment content disposition. That will force a download rather than displaying inline. If the upload is only for images, then you should be removing EXIF data from JPEGs, ancillary chunks from PNGs, and all other extraneous data. This is because they make great hiding spots for HTML and other potentially malicious contents. While this may not be exploitable today, a small change can make it exploitable tomorrow. Removing the data is the only truly safe solution. The most important thing to remember when dealing with file uploads is that the user cannot be trusted. Throw away any non-essential data, period. Every single bit of data is one additional place that could be used for an exploit. If you're handling images, throw away everything but the actual image data. If you're handling archive files, unpack it and repack it to prevent structural exploits, like file names containing directory traversal payloads. Don't trust anything that you don't have to. Well, that wraps it up for this session. As always, thanks for watching and happy breaking.